Okay, this lesson we're going to focus on integration of these two functions. So if you will take a few minutes to pause it and write down your theorems. And then afterwards we're going to, you also have another page with some theorems that we're going to write down. And then we're just going to show some examples of actually using the application of these. So the antiderivative of 1 over u du is going to be equal to the natural log of u plus a constant. And then the other one down here is the integral of e to the u du is equal to e to the u plus c. So this is integral of 1 over u du. Okay, in addition to your indefinite integrals on page 242 in your textbook, here are 4 more specific ones. So if you will take a few minutes to jot these down as well. And then recall the ones on page 242. So those are one we covered previously. Okay, one other thing I want to call your attention to before we go ahead and start some examples is that this first one, let me see if I can move up some. The integral of tangent u du is equal to the negative natural log of the cosine of u plus constant. That's what we have right here, but sometimes you will see it written as the natural log of the secant of u, and how that simplifies is using your property. So if I take this power and move it back as an exponent, it becomes to the negative 1 power, which would be 1 over the cosine of u, is also equivalent to the secant of u. So later when we see this in an example, I want you to see where we got that from. So these two, this and this, are equivalent. Okay, so our first example we have here, the integral of 2x to the third over x to the fourth plus 1 dx. And this one's looking a little complex. So we're going to use u substitution here. And I can also see that if I let this be u, the derivative of this would be 4x to the third. And I'm seeing this x to the third here, so I'm feeling pretty good about that. But even if you're not very skilled with it yet, you can try and till you find the one that works. So I'm going to say let's let u equal x to the fourth plus 1. What would du be? 4x to the third dx. Okay, so when I come back over here and I rewrite this, I would have 1 over u du. Now let's see what all that takes care of. So the 1 over the u is the x to the 4 plus 1, so this is taken care of. Du is 4x to the third, so the x to the third, we have a 2 and this term has a 4, so what can we do? Pull a 1/2 out front, so then that would just take care of that, and then of course our dx and this dx. So you just want to check to make sure everything's accounted for. And now we'll just bring down our 1/2, and by definition the integral of 1 over u du is just going to be the natural log of u plus a constant. Now we can leave our answer there in terms of u, or just for the sake of the practice of it, we can replace our u with our x to the fourth plus 1 plus a constant. So sometimes the format of your answer will be left in terms of u, and sometimes they'll go through the extra step and plug it back in using your information up there. Okay, this next example we're going to have 2 parts. The first thing we're going to do is the indefinite integral over here, and then this one's going to be a definite integral from -1 to 8. So go ahead and try this one. It's similar to what we did a minute ago, and then we'll come over here, we'll work both parts. Okay, so u is going to be 4 minus 5x. Our du would just be what? -5 dx. Good. Now when I want to rewrite this, I'm going to have the integral of 1 over u du. Now let me check to see what that 1 and then over my u. So this is accounted for. Dx. So the only thing that's not, or that's different, is this -5. So we're going to accommodate that by pulling out a -1/5. Okay, so now we're ready to simplify this. Let's just bring down our -1/5. This is the natural log of u plus a constant. We'll go one more step to plug in replace our u with 4 minus 5x plus a constant. Okay, so either one of those are the correct answer. All right, the next thing we want to do is we want to come over here and evaluate part B. Okay, and be careful, make that a correction right there. That's a 0, not an 8. So if I just take my previous solution over here, and I'll have -1/5 the natural log of 4 minus 5x, and we evaluate that from -1 to 0. Okay, I'm going to go ahead and pull this -1/5 out, and then that would just give me the natural log of 4 minus 5. I'm going to put a parenthesis where that x is going to be, and then okay, so for the first one I'm going to have a 0 here, and over here when I plug in for x I'll have a -1 there. Okay, continuing to simplify, I'll bring this down the natural log. Now inside here I'm just going to have 5 times 0 is 0, 4 minus 0 is just the natural log of 4, minus over here, this is just going to be a negative times a negative is a +5 plus 4, so that's the natural log of 9. Okay, so I'm going to do this next step, and I want you to think for a minute to see what do you think I've done here. Okay, so what do we do on that step? Yes, we changed this, made it positive, and then switched the order of these two. So that's something that I want you to see that we're able to do at Tom's. That's one of our tools that we will work using the properties. Now, what else can I do with these natural logs? Can I rewrite subtraction as a single term and rewrite it using division? So I'll just bring this 1/5 down, and this could be rewritten as the natural log of 9/4. And then you want to put this in your calculator, and we'll get an approximate value. Actually, I'll come down here. Approximate value of 0.16. Okay, before we move on, I'm not necessarily going to work this out, but there was also another method we could have used over here. What if we used this one, leaving it with the u? We would have had the similar processes, but what would be the only difference? If we use u, then what about these? These need to be converted over to be relative to u. So for example, if when x equals -1 right here, u is equal to 9. So you would put -1 in right there, and you would find that u equals 9. So these would change in respect to u. So really you have an option to either work with the u term and change your interval, your limits right there, or you can put it in terms of x and use the original one. So you have some options there. You should still get the same answer if you do the math correctly.